Faraday's God, London, 1831. Michael Faraday, the man who did the most to uncover these invisible force fields, was a curly-haired, working-class Londoner who was born in 1791, more than a century before the electron was discovered. He was exuberant as a teenager, teasing his friends with wordplay and games as they raced down the London streets, replying once to a letter from his friend Benjamin Abbott. No, 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 none, right, no philosophy is not dead yet, no, no, oh no, he knows it, thank you, 'tis impossible, bravo. In the above lines, dear Abbott, you have full and explicit answers to the first page of yours dated September 28th. Even when he wangled his way into a job as laboratory assistant at the August Royal Institution in 1813, he kept the same humor. On one memorable evening, sneaking Abbott in so they could sample the nitrous oxide, laughing gas, which the director of the institution had put aside for one of his experiments. But Faraday also had a serious side, and was drawn to the same electrical puzzles that Joseph Henry sought out. How could a coiled copper wire act as a magnet and pull lumps of metal toward it? There was only empty space between the wire and the metal. Nothing in conventional science made sense of this. Hold such a live electromagnet above a nail, and the nail will fly upward. Yet the gravity of uncountable trillions of tons of rock and magma, the entire mass of the earth, is tugged down on the nail. What pull could a magnetized coil of copper send out that would overcome that vast force? Faraday was fascinated. It's what he dreamed of unveiling, but for years he was barely allowed to work on such problems. Rumors were being spread behind his back that this one-time slum child, this offspring of a mere blacksmith, was not really capable of serious research. But by 1829, the Royal Institution director who'd slurred him the most had conveniently died. Faraday gave his most sincere compliments to the director's widow, immediately dumped the assignments the director had given him, and cleared his work schedule as much as possible. He couldn't put the invisible drawing power of magnets out of his mind. He had to know how it worked. In this investigation, Faraday had one great advantage over his rivals in England and on the continent. They had all been trained in the advanced mathematics that Sir Isaac Newton had developed in the 17th century. Newton was famous for the image of a cold, clockwork universe where planets rolled along like giant, separate billiard balls. There was no place in that universe, they were now taught, for invisible forces to fill up the space between solid objects, holding the solar system or the universe together. There were no invisible cobwebs pulling across the sky. Gravity existed, but it somehow leaped from object to object. In this view, it did not permeate the voids in between. This meant that when Faraday's contemporaries tried to understand the links between magnetism and electricity, they assumed it would have to be a force that leaped across a gap without really existing in the space within the gap. Their universe was basically empty. When forces operated, it would have to be, they believed, through the cold, distance-leaping process that Newton had labeled action at a distance. Faraday respected Newton, but he'd been supporting himself from the age of 12, for years as an apprentice bookbinder. He'd learned to think for himself. If he'd gone along with what everyone assumed, he would probably still be at the binding shop. Also, in his years as an apprentice, he'd skipped learning much mathematics beyond elementary arithmetic. This had the further advantage that he'd never been seduced by the beauty of Newton's Bach-like equations. But even if he hadn't been poor, and even if he hadn't learned calculus, there was a further reason Faraday wouldn't have been convinced that space was empty. Faraday's family had been devout members of the gentle religious minority called the Sandemanians, a Quaker-like group with a near-literal belief in the Bible. Even as Faraday moved into the Royal Institution, he remained a devoted member. His wife was a Sandemanian, and his closest friends were as well. From his religion, Faraday was convinced that space was not empty, but that a divine presence was everywhere. He was used to being ridiculed for such beliefs. Quote, "I am of a very small and despised sect of Christians," end quote, he once sighed, and he had learned to keep his views private. But religion dominated all his thoughts, and once, on a small boat in Switzerland, Faraday saw what he took as a proof of his beliefs. It was an ordinary rainbow at the base of a waterfall, but a strong wind was blowing, and gusts often threw the spray so far to the side that the rainbow disappeared. When that happened, Faraday motioned for the guides he was with to wait. Every time the wind blew the spray in the opposite direction, and the rainbow reappeared. Quote, "I remained motionless," Faraday wrote, "whilst the gusts and clouds of spray swept across its place and were dashed against the rock." End quote. It was, he felt, as if the rainbow were always waiting, even though it could only sometimes be seen. That was what he believed of science. Even when space seemed empty, something was there. Now, looking for a further link between electric currents and magnets, he knew to concentrate on the one thing everyone else had missed, the apparent, quote, emptiness, the voids between the different objects in his lab. He used a simple clue as the way in. A common parlor trick of the time was to sprinkle iron filings near a magnet and then watch as they formed curves that stretched from one tip of the magnet to the other. To Faraday, this wasn't just a trick to amuse children. For where did the sudden arcs really come from? They were a sign, just like the rainbow, of the invisible matrix for which he'd been searching. Through 1830 and increasingly in 1831, Faraday began circling his quarry. He became fascinated by the way forces seemed able to jump from one domain to another. When clouds of gas vapor ignited, for example, it was common to say that a ball of flame instantly appeared. Faraday didn't believe that. When he stared more closely, he felt he could see the flame propel itself very quickly from one part of the vapor to another. When he went to the seashore in Hastings, a long day's coach ride from London, his wife found him kneeling on the bench to examine the ripples in the sand, pondering how they spread. It was something that Edison would never have had the time to do. By the spring of 1831, he was close, but still hadn't found what he wanted. He was 39 years old, and in many of the years the Royal Institution's director had kept him at bay. He hadn't come up with any significant discoveries. Had his critics been right in suggesting that he wasn't a first-rate thinker after all? Faraday cut back on his lecturing and began arriving even earlier at his lab. Occasionally his two nieces would come downstairs to visit, but they knew they'd have to spend most of their time sitting quietly in the corner, cutting out paper shapes or playing with their dolls while Uncle Michael worked. Months passed, colleagues wondered what was happening, and then, in work that came to a head in those pressure-soaked weeks just before a 40th birthday, one of his oldest friends, Richard Phillips, received a quick note. "My dear Phillips, I am busy just now again on electromagnetism, and think I have got hold of a good thing, but can't say. It may be a weed instead of a fish that after all my labor I may at last pull up." It wasn't a weed, and after a few more days' work he had the decisive result. By October he was able to present it in an immensely simple form. He merely held a child's small bar magnet in one hand and a coiled wire in the other. He pushed the magnet toward the coil of wire, and an electric current started up in the wire. He held the magnet still. The current stopped. He moved the magnet again. The current started up again. So long as he moved the magnet in the vicinity of the wire, he created an electric current. No one ever had understood this before. He created a force field. Something was traveling from the magnet into the wire, but that couldn't happen if the space between them was empty. There in his cool basement laboratory at the Royal Institute, with the horse-drawn traffic of Regency London pounding outside, Faraday had shown that electricity wasn't some hissing liquid that could only be funneled along inside a wire. Rather, it could be brought into existence by an invisible force that spread from a moving magnet and stretched across empty space. Faraday had opened the door to something greater than anyone had imagined. If he was right, then whenever his nieces playfully tugged a toy magnet, they were also tugging an invisible force field that spread out from the metal of that moving magnet. As best Faraday could estimate, the force field stretched on forever. If he and his nieces were inside a building, part of the force field would stretch outward through an open window, or perhaps even through the wall, absolutely invisible, and continue to the moon or possibly beyond. It got stranger. Faraday's basement experiments suggested that our world was filled with untold millions of these invisible flying force fields. There were hundreds of ships in the London ports and thousands of carriages on the London streets, and wherever any mariner or coachman's magnetic compass needle moved, yet more of these invisible fields would be loosed. When Faraday looked out at Regency London, the sky wasn't empty above him. It was arcing with these powerful, invisible presences. Quote, "The book of nature which we have to read," he'd once written, "is written by the finger of God." End quote. He was right, and now he had shown that God was a flamboyant, hallucinatory Titan, blasting his universe with hitherto unseen vivid streaks. Faraday's insights are at the heart of modern technology, and even, as we'll see, would eventually answer the question about why electrons don't pile up at the end of a long phone line. But although he now held a distinguished position at the Royal Institution, he hadn't outlived his past. Most of his English colleagues believed that he was only a clever tinkerer. They knew about his embarrassed lack of formal education. They'd seen that he couldn't express his insights in the advanced mathematics they so easily used. To all but a few of them, his excited theories of invisible force fields seemed entirely unfounded, and so his ideas were politely set aside. Faraday made many more discoveries. He had audiences with prime ministers. He became greatly respected for his popular lectures. At one point, a brilliant young woman became fascinated by what his electricity findings might suggest for her own research. This is one of the great, quote, might-have-beens of history. For the woman was the late Lord Byron's daughter, Ada, Countess of Lovelace, and she'd been working on early notions of what we'd now call computer programming. No technology of the time could entirely build what she envisaged, but who knows what Faraday might have come up with. He seemed entranced by her, but soon stepped back, probably to avoid jeopardizing his own marriage. He still didn't give up, though. When he'd been criticized for his religion, he had turned to the Bible for consolation. Now criticized by the great majority of researchers for his idea about force fields, he turned back to Isaac Newton. Although Newton was said to have had a different view about empty space, maybe that wasn't quite true. Newton was the greatest thinker science had ever produced. Even a hint in his writings that Faraday might be right would be comforting. On the surface it would seem impossible, but in fact Newton had once revealed doubts about his public vision in a brief relaxed moment in his old age. To an inquisitive young Cambridge theologian, Richard Bentley, Newton wrote in 1693 that perhaps the universe wasn't so empty. Perhaps, on the contrary, there really were forces, such as gravity, that sent out tendrils crisscrossing what seemed like empty space. The idea, quote, that one body may act upon another at a distance through a vacuum without the mediation of anything else, Newton daringly wrote, is to me so great an absurdity that I believe no man who has any competent faculty of thinking can ever fall into it. End quote. Bentley had been excited and had written to find out more about what the great scientist meant. But Newton drew back. These were just an old man's musings, and nothing further was to be said. To have gone further would have been dangerous, for this was an era when religious heretics were still burned at the stake. The authorities might misinterpret his belief that space was not empty, and assume he didn't believe God's power was great enough to cross empty space. They might begin to investigate his private religious writings, which definitely were full of heresy. The correspondence stopped, and his brief hint of self-doubt in that letter to Bentley was soon forgotten. But now, more than 140 years later, as Faraday was hunting for confirmation that he hadn't been entirely wrong, he found Newton's very old letter to Bentley. With that, Faraday realized he wasn't alone. Newton had been there before. Beyond that, Faraday couldn't go. In his old age, his memory already fading, he wrote to a young friend, the gifted Scottish physicist James Clerk Maxwell. My dear sir, there is one thing I would be glad to ask you. When a mathematician engaged in investigating physical actions and results has arrived at his own conclusions, may they not be expressed in common language as fully, clearly, and definitely as in mathematical formula? If so, would it not be a great boon to such as we to express them so, translating them out of their hieroglyphics that we almost might work upon them by experiment? Maxwell wrote back diligently, but Faraday remained left behind. His weakness in mathematics had helped him start a major inquiry, but he was never going to be able to lead its further development in his lifetime. Still, Faraday consoled himself by taking a long view. He was convinced that someday there would be practical inventions that depended on what he'd seen. When that finally occurred, even the critics who dismissed him would have to accept that his hunches were true. What he didn't realize as the decades went on, and he was reaching 60, was that he would live long enough to see it happen. A giant engineering adventure was soon to take place, deep under the sea. When it was completed, there would be tantalizing further evidence that everything he'd imagined about invisible force fields was really true. This was Chapter 4, narrated from the book Electric Universe, written by David Bodanis. Page 61 through 70.